Welcome everyone. In this video lecture, we will solve a diode problem which is from the microelectronics circuit book. So the question is a particular diode for which the ideality factor eta is 1. Okay, what it means? The eta value is 1 means the diode is made of using standard IC fabrication process. Okay, is found to conduct a 5 milliampere current with a junction voltage 0.7 volts. So we have to find the saturation current is. Okay, so this is the first part. So I am just mentioning the given thing from the first line. What will the ideality factor 1 is given for a particular diode, and it is conducting a current having id, we can say 5 milliampere with a junction voltage vd 0.7 volt. Okay, so we have to find the is. Okay, saturation current, the first part up to this. Okay, now what current will flow in this diode when the junction voltage is raised to 0.71 volt to 0.8 volt. So the question is, in the same means diode, if the junction voltage is 0.71 volt and the junction voltage is 0.8 volt, okay, what should be the current id, okay, for this particular voltage vd. Okay, if the junction voltage is lowered, okay, if the junction voltage is lowered means, again the question is vd is somehow 0.69 volt to vd 0.6 volt. Okay, 0.69 volt to 0.6 volt. So what should be the current? Okay, so the same current we have to find id for this also. Okay, simple. And what change in junction voltage? Okay, what change in junction voltage will increase the diode current by a factor of 10? Okay, what change in the junction voltage? So for that thing I am just writing what change in the junction voltage. Change means the difference, vd1 minus vd2 we have to find, or we can say the vd2 minus vd1. Okay, what change in junction voltage? It may be either vd2 minus, or better to write vd2 minus change. Okay, means when junction, what change in junction voltage will increase the diode current? Okay, will increase the diode current by 10 times. Okay, I2 by 10 times of I1. Okay, so I2 equals to 10 times of I1, so VD2 will be higher. Okay, so better to take this one. We have to find this change VD2 minus VD1 for. Okay, we have to find this VD2, what change in junction voltage. Okay, so VD2 minus VD1 I am writing, which will cause a increase in the diode current by a factor of 10. Okay, so this is the other part. So these are the thing we have to find. So we have to find vd2 minus vd1, and the diode current is just increased by 10 times of I1. So what should be the change in the junction voltage? Okay, so first we have to start with this portion. Okay, this one is the data. From this data we can easily find the saturation current is. So for that purpose what we have to write, id, drain current, oh sorry, diode current, not drain, equals to is exp vd by eta vt. Eta is given 1, so one can also write the is, the saturation current, is id upon exp vd by eta vt. Okay, simple mathematical uh, formula is there. Then we have to write like this, is equals to, because id is given, vd is given, everything is given. So now the only the calculation part we have to do. So id is 5 milliampere, so better to write 5 into 10 to power minus 3. Okay, we have to write exponential. vd is also given 0.7, 0.7. Okay, eta value is 1, so 1. And vt is our thermal voltage 25 millivolt, so 0.025. vt is given means, for anything vt is 25 millivolt, so 0.025. Okay, so this one is the final. Okay, so one can solve this like this: 5 into 10 to power minus 3 exponential. Okay, I am just putting here minus. Okay, then 0.025. Okay, clear? And if we solve this one, it will, I have already solved, but I'm writing here exp minus 0.7 divided by 0.025, it will come nearly minus 28. And if we solve, okay, by using calculator, it will come 3.457 into 10 to power minus 15, or femto we can say ampere. Okay, so this one is the saturation current. Basically, we have to start with this ID. Okay, then we have written the this IS expression, and after solution, the final IS is like this. IS equals to, as I'm writing, IS equals to this. Clear? So this we have already find. Now we can find the value of ID by just taking this IS. Okay, so this one is the first part of the thing. So now we have to think about this one. Okay, for this purpose, now again what we have to do, for ID we have to find IS is now known to us. Okay, so what we can do, we have to just simply write the expression for ID equals to IS exp exponential Vd by eta Vd. Okay, then after, what we are doing here, what we can say, IS is now known to us, so simply we have to write 3.46 we can write. Okay, into 10 to the power minus 15 exp Vd. Vd is given 0.71, eta is 1, so 1, 0.025. Okay, so this one is the thing. So if we solve 3.46 into 10 to the power minus 15 exp, okay, 0.71 by 0. This will be around 28.4. Okay, so if we solve this one, finally what we will get, 7.46 into 10 to the power 12 into 10 to the power minus 15, so it is nearly 7.46 milliampere. Simple calculation is there, so ID will be around 7.46 milliampere. Okay, so this one is one part of the question. Okay, now the second part for this one. Okay, so for this one what we have to do, again we have to start. Okay, same expression, ID equals to this. So what we can write, ID, I am not writing this expression again, IS 3.46 into 10 to the power minus 15 exp. Okay, Vd value is given 0.811 into 0.025. Okay, so then if we solve this one again, what we get, some numerical thing. Okay, we have to calculate it, so I have already calculated. So for this one, finally what we will get, 273.21 milliampere. Okay, this one is simple calculation, so you have to do. Okay, so this one is the second part of this one. Now for the next one, for this one, when the Vd is lowered, so for this purpose, again we have to find the ID. So for ID purpose, again we have to write, because saturation current will be same, because for the same diode I am using exp. Now this one is lower down. Okay, so 0.69 divided by 0.025. Okay, 1 into multiplication is there, so no need to write too many things. So it will around 3.35. Okay, 3.35 milliampere it will come after solution. Okay, so for this one. Okay, now for the next one. Okay, for this one. Okay, so for this again we have to write ID 3.46 into 10 to the power minus 15 exp 0.6 by 0.025. Okay, so if we solve again, it will come 91.65 microampere. Okay, so like that we have find. So the first thing we have to find this one, saturation current for this data. Now we have to go for the last portion, means what change in the junction voltage. What change in the junction voltage will increase the diode current by a factor of 10. Okay, so for this purpose what we have to do, I'm writing, means we are just starting with the basic, means as we know I1 equals to is exp. Why I am writing, you will get vd1 by eta is 1, so 1 into 0.025. Okay, one more line I am writing for I2 diode current I1 I2 I am for is exp vd2 by 1 into 0.025. Okay, we are doing for this portion, this one. Okay, clear, means vd2 minus v2, we have to find difference. Okay, so these two we have written, and in the question it is given I2 equals to 10 times of I1, means what should be the change in the voltage will cause the increase in the current outcome by a factor of 10. So I2 equals to 10 times of I1. Okay, so one can write this I2 by I1 equals to 10. Okay, very simply. So now what we can write, I2 equals to 10 times of I1. So here one can write this as a IS. Okay, or simply I'm writing here I2 by equals to I2 by I1. Okay, is 10 by this one. So now I2 can, and IS, this IS will be cancel out. Okay, all right, just IS exp VD2 by 0.025 by IS exp VD1 by 0.025. Okay, this IS will be cancel out, or this, this can be written as VD2 minus VD1 by 0.025. Okay, simple calculation, I2 by I1. So now we have to find this VD2 by VD1, the difference in what, difference in the voltage. So VD2 minus VD1 we have to find. So one can write this as a VD2 by VD1 by 0.025 equals to ln 10. Okay, simple. Then after we can write VD2 minus VD1 equals to ln 10 ln 10 0.025. So this value everyone have to know, 2.3025 into 0.025. Okay, so if we solve this one, it will come 0.05756, and if you have to write in the millivolt, it is somehow 57.56 millivolt. So the change will be VD2 minus VD1 will be 57.56 millivolt. Okay, so this is all about this question. The last part is little bit tricky, but we have to very careful about this two term. Okay, and it is question given the current will be 10 times of the original one. So I2 is 10 times. Then after writing this difference, they are asking VD2 minus VD1, that we have find by using this one. So it is all about this question. So thank you for watching this video.